So this is the batch reactor electrical setup. It consists of a motor, it consists of a shaft, so it consists of an agitator and a cylindrical vessel. So in the procedure, so you need to prepare 4 different solutions. So first one is sodium hydroxide, 0.1 normality, ethyl acetate, 0.1 normal, oxalic acid, 0.1 normal, and HCl solution, 0.1 normal. So firstly in the procedure, so we need to transfer exactly 1000 ml of ethyl acetate to the cylindrical vessel. So and then you need to transfer 900 ml of sodium hydroxide. As soon as you add 900 ml of NaOH to this vessel, you need to start the stopwatch simultaneously. So once the stopwatch is started, so at a definite time intervals, that is 5-10 minutes, 15, 20, 25, up to 60 minutes, so we will be collecting the samples. So this 10 ml of the mixture pipetted out will be transferred into conical flask containing HCl solution. So the role of HCl is to arrest the reaction. So as soon as the reaction is arrested, so you need to titrate the mixture against sodium hydroxide which is taken in the burette. So the endpoint will be pink to colorless. Reactor experiment, the observation and calculations. So after the standardization of NaOH, we need to note down the values of V1, that is volume of oxalic acid taken in the conical flask, that is 10 ml. The normality of oxalic acid is 0.1 normal. The volume of NaOH rundown in the burette is whatever the value we get. So based on that, we need to calculate the value of normality of NaOH, N2 which is equal to N1 V1 divided by V2. So we get some normality. So then standardization of HCl. So the volume of HCl taken in the conical flask, that is 10 ml. Volume of NaOH rundown. So whatever the value that is NaOH rundown during the standardization of HCl, that value, and the normality of NaOH which we have already calculated here. So that value to be noted down. So the normality of HCl will be equal to a value. We will get it as 0.1 normal. So then the observations. So serial number. So we have taken different values at different intervals of time, starting from 5 to 60 minutes. So we need to note down the time readings in the first column, and the volume of NaOH rundown, that is the burette reading, will be in the second column. So the calculations. So first is strength of NaOH, that is N2 which is equal to 0.1 normal. Strength of ethyl acetate, which is given by 10 into density divided by molecular weight, that is 10 into 0.9 divided by 88. So we get it as 0.1 gram mole per liter. So the initial concentration of NaOH, which is equal to N2, that is 0.1 normal, and that of ethyl acetate is 0.1 normal. So then we have to calculate the ratio of initial concentration of Cb0 by Ca0. So we get it as greater than 1. So after calculating M, we have to calculate the concentration at the exit, that is at the outlet concentration. So which is given by N2, that is normality of NaOH, multiplied by V4. V4 is nothing but volume of NaOH rundown during HCl standardization, minus V5. V5 is the burette readings, divided by V mixture. V mixture is 10 ml. So we get the value of Ca. So after calculating Ca, we have to calculate conversion, that is Xa. Xa which is equal to 1 minus Ca upon Ca0. So after calculating the conversion, so we need to calculate the final K value, that is the rate constant value. So for that we need to tabulate in the final column. So time of reaction, that is 5 to 60 minutes. The concentrations, so which we have already found out here. So the conversion is also found, and the value of Y. Y is nothing but equal to K into T. So which is given by 1 divided by Ca0 into M minus 1 multiplied by ln of M minus Xa divided by M into 1 minus Xa. So all the values are known. Ca0 is the initial concentration of sodium hydroxide, M is the ratio, and Xa is the conversion. So after calculating the values of Y, we need to calculate the values of K, which is nothing but the rate constant. So the average of these values gives you the average specific rate constant. So after calculating the final values, so we need to plot the graph. So we need to plot a graph of Y versus T. So Y is calculated here and the time data is here. So we need to plot a graph, so which we get in the form Y is equal to mx. So and we get the slope as the rate constant. So the same has to be reported here in the result.